Okay, students, so we're doing a topic called equal matrices. And for two matrices to be considered equal, they must have something. So I call them the must-haves. One, they must have the same order, and we know what order is. And they must have corresponding elements that are the same. And we learned about corresponding elements when we did addition and subtraction of matrices. So let's compare two matrices, A and B. So we said that A is equal to B because they have the same order. Both of them are 2 by 2 matrices. And each corresponding element is the same. Corresponding elements are the same. 5, 5, 9, 9. We can see it there. Very basic. So let's check these matrices X and Y. We say that they are not equal, and let's see why. Both of them are 2 by 2 matrices. So yes, they have the same order. But when we observe row 1 of both matrices, we see that although the elements are the same, the positions are different. Therefore, they are not equal. So it's not just that they must have the same order, but their corresponding elements must also be the same. Okay, so let's see what we can do with equal matrices. So now we're going to look at equal matrix equations. For this to occur, there must be something that is stated. It must be stated that two matrices are equal. So this must be a given principle or fact. So let's watch this example. We have the matrices A, which is a matrix 2, 1, 6A, and B, which is a matrix 2C, 6, 3. And we are asked, if A equal to B, find the values of A and C. So we know that they are equal because we are told that they are equal. This was the rule set. And when we compare corresponding elements, we see that they are the same. So therefore, if 1 is in this position and C is in this position and they are corresponding elements, then C is equal to 1. Similarly, if A is in this position and 3 is in this position in the corresponding matrix, then A is equal to 3. And this is what corresponding elements being equal means. That if we are told that two matrices are equal, their corresponding elements are the same. So let's quickly move on to this next example. We have two matrices K and L, and we are told that they are equal. And they want us to find the values of X, Y, and Z. So when we compare, we see that 2 is in this position and Y is in this position. So therefore 2 is equal to Y. When we compare again, we see that 9 is in this position and we see that Z squared is in this position. So 9 is equal to Z squared, which means that Z is equal to the square root of 9, which is 3. Plus or minus 3. And then finally, we see that we have X in this position and 10 in this position. So X is equal to 10. So what equal matrices do is they create a condition for by which we can now pull out of two matrices algebraic relationships. We can pull out equations that sometimes we have to solve, or that would typically or sometimes be straightforward answers. So this is more or less equal matrices in a nutshell. I will do another example for you when they combined equal matrices with addition and subtraction of matrices. Hope this was helpful.